Good morning to everyone. Myself is Devi, Assistant Professor, Department of Artificial Intelligence and Data Science. I am going to teach the subject Data Structures using C++. Today we are going to discuss about the topic Graph Traversal. Graph traversal is a technique used for searching vertex in a graph. The graph traversal is also used to decide the order of vertices visited in the search process. A graph traversal finds the edges to be used in the search process without creating loop. That means using graph traversal, we visit all the vertices of a graph without getting into the loop path. There are two graph traversals. They are DFS and BFS. DFS means depth first search. BFS means depth breadth first search. We are going to discuss about DFS in this section. DFS traversal of a graph produces a spanning tree as a result. A spanning tree is a graph without loop. We use tag data structure with maximum size of the total number of vertices in the graph to implement DFS traversal. These are the steps involved in DFS traversal. The step 1 is define a stack of size total number of vertices in the graph. Step 2 is select any vertices as a start point for traversal. Visit that vertex, you push it onto the stack. Step 3, visit any one of the non-visiting adjacent vertices of the graph which is at the top of the stack and push it onto the stack. Step 4 is repeat step 3 until there is no new vertex to be visited from the vertex which is at the top of the stack. 5 is when there is no new vertex to be visited, then use backtracking and pop one vertices from the stack. Step 6 is repeat step 3, 4, 5 until stack becomes empty. Step 7, when stack becomes empty, then produce final spanning tree by removing unused edges from the graph. Backtracking is coming back to the vertices from which we reach to the current vertex. Consider an example. Graph is given. We have to construct a tree with the help of DFS. We are using stack data structure here. The step 1, we have to visit only one vertex at a time. We have to choose a start vertex first. So consider A as the start vertex, push it onto the stack. 2 is from A, we can visit a vertex. We have to visit only one vertex at a time. So visit B, which is in alphabetical order. So we are visiting B, which is not already visited. Then push B onto the stack. From B, visit a vertex, say C, which is adjacent. If C is adjacent, there are many vertex which is adjacent to B, that is C, E. Both the vertices are adjacent, but we are visiting in alphabetical order. So let us visit C. So push C onto the stack. The step 4 is from C we have to visit the only one vertex. For C, E, F, G are the adjacent vertex, where E is the vertex which comes first in the alphabetical order. So visit E first. So push E onto the stack. Next step 4, from E visit other vertex which is adjacent. So D and F are adjacent, but in the case of alphabetical order we are going to visit D. So push D onto the stack. From D we cannot visit any other vertex, since for a D, A and E are the adjacent vertex which is already visited. So backtracking takes place. So from D and we comes to node E, and from node E we have to visit another node. See the adjacent node where B, A, C, F are the adjacent node, where A, B, C are already visited and F is not visited. So visit F and push it onto the stack. After visiting F, visit the adjacent vertex of F. C, E, G are the adjacent vertices of F. So where E and C are already visited, so visit G. After visiting G, push the G onto the stack. So in the 9th step, all the vertices are in the 8th step, all the vertices are visited. In the 9th step, we have to backtrack G to F. We have visited G through F. So backtracking take place and come to F. While backtracking, pop the top element from the stack. So G will be popped from the stack. In the 10th step, from F, all other adjacent vertices are visited. So backtracking take place and come to E. So delete F from this tag. After that E, all the other vertices are visited, so backtrack to D, delete E from this tag. And then from D, all the other vertices are already visited, so from E we have to backtrack to C. Back to C. From C, already B is visited, so backtrack to B. Delete the element C from stack. Then from B, only one adjacent node is there, that is A, which is already visited, so backtrack to A and delete the node B. So start vertex is A, which is already visited, so delete the node A. Now the stack is empty, so this process completed. After this, we have to construct a spanning tree here. So the below given diagram is the spanning tree of the given graph. So this is how the DFS is works. Depth firsts. In the case of depth firsts, we have to visit only one vertex, adjacent vertex at a time. Here we are using stack data structure. This is all about DFS, depth first search. We can see the next topic in the next section. Thank you.